CCS 223 Data Communications and Networks. And let me introduce myself. My name is Konglit Anjangsit. I'm a full-time lecturer at Faculty of Engineering, Department of Computer Engineering. So this is my first time that I meet you. So nice to meet everyone. My background, I got bachelor degree in electrical engineering, specialized in signal processing, and my master in also electrical engineering and in telecommunication and network. And my PhD is in information technology. So I have been teaching datacom and network for a long time, but for Thai program, engineering Thai program, and that's 15 weeks. So for this class is about 12 weeks. So I have to compress some of the content into this 12 weeks. So I got to select I'm going to go wide and not so deep. There's so many topics in this area. Let me ask, is this your first class in communications or in networks?
Yes.
So far, yes.
Okay. So this class going to be a foundation for you in this area. Okay. What I mean by foundation is that many things in this area change really fast. So you need to keep track. Keep learning. Okay, everything changes so fast. The technology changes so fast. So what we're going to learn in this class is going to be basic, fundamental. Okay, and we're going to see how networks and communications have been developed to this point, and it's going to be a foundation so that you could go and read and learn by yourself later on in many areas that concern communications and network. Okay, I post a syllabus post on the Google Classroom. So let me, before we go to the syllabus, maybe it's nice just to get to know you a bit. I have 14 students on my list. I would like to call out your name, and could you just say hi? Okay, could you just turn on the camera so I know who's in my class? Anuvit. Hello.
Yes, Captain.
Where are you?
Let me try and wait. Can you see?
Okay.
It's kind of dark.
No, I don't see you. Oh, Anuvit. Okay, nice to meet you. Anantate. Is that correct?
Yep.
Okay, nice to meet you. And Sumed, ครับ Sumed. Not here, right? Okay. แล้วลินทิพย์แล้วลินทิพย์
Hi.
Hi which one are you I don't see you I only hear your voice แล้วลินทิพย์
My camera is on though.
Oh it's okay your camera is on but I cannot see you oh I see you now okay okay nice to meet you เกรียงศักดิ์ครับเกรียงศักดิ์ Are you here
Sorry, I was muted. Could you see me? Could you see me?
Oh yeah yes okay thank you nice to meet you
Nice to meet you too.
is that Grit right is how to pronounce your name
I'm here ครับ
No. Oh okay nice to meet you ธนากรช่วยนี้อยู่ธนากร not here ไทยรัฐ
Hello.
hello ครับ okay nice to meet you พงศธร
here
yes okay nice to meet you พงศธรทศวรรษ I guess he's not here วิกรม
I'm here.
okay yes nice to meet you สุภกฤต
Yes ครับ
okay nice to meet you ครับนัฐการ
Yes.
okay nice to meet you ครับ Patrick
Hello, John.
where are you oh I see oh driving
I'm going
All
to
right.
go to a cafe.
okay you may turn off your camera nice to meet you Patrick ICMI what major is that
That's business, but like I haven't changed my major yet.
oh but
But I've been
you're going
doing
to
computer
change
science. Right, I've been doing computer science courses for the last 2 years.
oh all right
But since,
okay
well, not I don't
Okay.
recall how long, but I haven't had a chance to go to the OAA since COVID.
Okay. Thank you. All right. Let's take a yes. Which one are you? What's the what? Okay. Don't worry because if you log in, it's going to be on the WebEx log. Okay. So. All right, and let's take a look at our syllabus. It's going to be a tentative one. Let me share my screen. Hold on. So we're going to study theories, technologies, and standards concerning data communication and networks. Okay, and by the end of this course, I expect you to be able to explain basic principle of data communication and computer networks. Okay, and should be able to understand communication protocol and understand standard of computer networks. And lastly, you should be able to design a basic computer network. You should be able to know component that require and how to make them work. Okay, and take a look. That's my name, and that's my email. I'm in engineering building, the red building. My room is 6264. I mean, if you, well, I guess I work from home, but I'm now in my office. So I think there's a chance that we're not going to meet each other in person this semester, I think. And the text actually are text not really required. Okay, I follow this book, the Photos on Data Communication and Networks, and I select. Actually, I have to say that I don't follow the whole text. So you use my slides, the PowerPoint slides, as the main guideline, and then you may have to I mean lecture. Okay, take notes. Before the exam, I will give you a review sessions. Okay, so you know what to expect on exam, and this is how the grading look like. So midterm 40%, final 40%, and homework and reading assignment 20%. Any comments? I'm going to assign you homework start from today. Basically, because if you want to be in this area, I mean communication and network, it's required that you read and follow technologies. Okay, so I'm going to assign you to read basically anything that concerns computers, concern communication technologies. You could read websites, magazine, newspaper, journal paper, and any topic of your interest at this moment. Any topic of your interest, and you will submit to me on the Google Classroom. I would assign you again on the Google Classroom, and some weeks I would assign you homework besides the reading. Okay, so and if you submit all the homework, you on time, you would get 20%. Okay, so basically I don't how I say it. I don't subtract the point off if you do it incorrect or correct or not correct. Okay, so you have to submit on time. You have to try every problem, and you have to submit what I told you. That's it, and you would acquire that 20%. And then the midterm would be 40, the final 40. And I have to say that the midterm and the final, you don't need what I say, after the midterm, when you take the final, you don't need the knowledge before the midterm to take the final. I would say that. Yeah. And let's take a look at our schedule here tentatively. So first week, this week going to be introductions. to data communications and computer networks. Okay. And then the second week, we're going to take a look. Actually, I would try to start this this week. The introduction to information, data, and signal. So there are differences between the term informations, data, and signals. Okay. They are not the same. Okay. Within the data, you have informations. Okay. Not all data are informations. And the signal would be something that carry your data, carry the information to the destination. Okay. And third week, we're going to take a look at digital communications. So the communication we have, we call analog communication and digital communication. We're going to focus on digital communications. A/D does mean analog to digital conversions. So we're going to talk a bit about when we want to send analog data or analog signal through digital network. So we have to convert from analog signal into digital signal. Analog signal, for example, my voice. Okay, so I'm talking to you right now. And actually my voice going through digital network. Okay, my voice get into the computer. So the computer need to convert my voice into digital data. Okay. So that the process of A to D, we call it A to D. And after it's become digital data, we're going to talk about source coding. Source coding is, you can say it's compressions. Okay. So when you have a big chunk of data, okay, you would try to throw away what the redundancy, that's the term, not something that not necessary to send. Okay. So you would compress them. So there's some compression protocol or algorithm here to compress data, and we call that process source coding. And you know some compression like zip files, even like MP3, MP4. That's some compressions standard. Fourth week, we're going to look at error control coding. Okay, error control coding. Communications. Because communication, we're trying to send information from source. That's what we call the source or the transmitter to the destination or the receiver. Okay, and the problem with communication, the main problem with communication, that we have what we call noises or interference. Okay, so basically along between the source and destination, you're going to have a lot of noises, and you sometimes have error when your data reach the destination. So we sometimes going to insert some code into your data so that it would help us control the error. Okay, and we call that code error control coding. All right. And look at a bit called the modulation. Modulations. Okay, let me explain. Modulations. Sometimes, for example, wireless. If you want to send information wirelessly, you have digital signal, even analog signal, such as my voice. If I want to send my voice wirelessly, I cannot just speak into microphone, and then, when I speak into microphone, my voice turn into electrical signal. Okay. That electrical signal cannot just go out of the antenna and go and travel to the destination. You need some what we call the carrier, some signal that have that could carry the voice. So we have carrier that carry the voice from the source to destination, and the process of mixing the data with the carrier we call the modulation. Okay, and we talk about line coding here. Line coding concern when we want to transmit digital data into wire. Okay, we're going to generate electrical symbol, okay. And that line coding. That's many different type of line coding. All right. So, and week 5, we're going to start into computer network. Okay. So week 1, 2, 3, 4, that's more like communications in general. Okay. And week 5, we start going into computer network. We're going to talk about switching techniques, and like our LAN, okay, local area network, computer network. When we send data, like today, the switching is called packet switching. Packet switching. The telephone network, we use technology called the circuit switching. So we're going to see the difference between switching, particularly circuit switching and packet switching. And then when we study network, we need to know this one, what we call an OSI protocol stack. OSI protocol stack is a standard from ISO. ISO stands for International Standard Organization. ISO have one standard called the OSI protocol stack. OSI stands for Open System interconnections. Hold on, let me record. All right. And this OSI protocol stack consists of 7 layers. So it's going to help engineers, communication engineer, to work with equipment. So we divide how the network work in 7 levels. Okay. And we're going to take a look at the protocol stack. And in this class, we're going to look into the first 4 layers. That's the first 4 layers concern communication network. The layer 5, 6, and 7 mostly concern application. So we're going to look a lot into layer 1, 2, 3, and 4. And layer 1, so week 6, we're going to learn about layer 1. Layer 1 is the physical layers. Okay. Concern the wire or wireless, concern the medium that the data travel. And then we go to layer 2. Layer 2 is called the data link layer. So layer 2, we're going to look at what we call the access protocol. Okay, so layer 2, we're going to have protocol that we're going to use to access into the medium, access into the layer 1. And there's many type of access protocol. The first type called the random access protocol. And we also have many protocol. Okay, We look at random access protocol because our LAN, our network today use random access protocol. So week 7, I hope we could have midterm on week 7. And then we're going to learn about the Ethernet. Ethernet is not internet, okay, different. Ethernet is LAN technology, okay. Internet is the biggest network in the world, right? The internet, we play the internet. This is called the Ethernet. And then with layer 2, with the access protocol, we're going to see the protocol called CSMA-CD, and then our LAN protocol. And then we actually this is wrong. The IP, I have to, sorry. It's not wrong. I will start talking about IP on week 3, but on week 8, but actually IP is not in layer 2, okay? IP is in layer 3. Okay. So layer 3, layer 4, we're going to take a look at the protocol for the TCP/IP. TCP/IP is the internet protocol. Okay. I'm going to look at IP address, look at how to do the subnetwork, how to assign IP address to each network, and how we could divide network into subnetwork. We're going to look at ARP, that stands for Address Resolution Protocol. We're going to deal with IP address, and we're going to deal with what we call the MAC address, hardware address. And there's some protocol that we call the ARP that's going to connect that IP address to the MAC address. And then we go up to layer 4. I'm sorry, not yet. Week 10, layer 3, we talk about routing. Okay, we talk about internet. And we also going to talk about equipment, okay, like hub, switch, router. And layer 4, you're going to see the protocol called the TCP and the UDP. So this is also internet protocol. Take a look at flow control. Sometimes some protocol would have what we call flow control, that control the congestions of the network. Okay. And then with 12, hopefully we could do a little bit of network design, and then we talk a bit about wireless LAN. Any comments on our schedule here? I would like to tell you that there are going to be many technical terms, okay, in computer network, a lot. And on the exam, I'll tell you the first question of the exam, the midterm and the final. The first problem, the midterm and the final, going to be about 4 to 5 questions. And the first questions, I'm going to ask you about the definition of the technical terms. Okay. For example, I could ask you, what is source coding? Just like that. what is ARP? You're going to tell me what it is. That's it. So that would be the first problem of the midterm and the final. Okay. Okay. But well, I'll give you the first exam problem. And so this class is 2-hour class. So basically, we'll start at 2 o'clock. So at 3 o'clock, I'm going to give you a break in the middle. Okay. Is that good? Well, 10 minutes break. Good. And I think it's good too, you know. I could show you a graph of your concentration. Okay. So basically, if start at time 0 here, if your concentration is up here, as time go by, it's going down, and at one point, I found out that most students, your concentration just exponentially decay like that. Okay. So what we're gonna do is we're going to interrupt this exponentially decay. We're going to give you a break here, so you could go up here. Okay. So I think if we lose 10 minutes, but we get better average of your concentrations. Okay. Otherwise, after that 1 hours, maybe nothing going in. All right, so that's what we're gonna do. And okay, let me I have to tell you communications and network here in this area. There's some mathematics, and the mathematics that you're going to see, I would say most of the time, would be probabilities. Have you learned, have you taken probability before? Yes, right? Yes or no? Yes. Okay. It's not difficult though. It's basic. Why? Why probabilities? Actually, if you're dealing with anything at all, not just communication, okay, that there's some uncertainty in the problem, you cannot avoid probabilities. And in communications, let me use my whiteboard here. In communications, okay, we trying to send what we call informations. Okay. Informations, okay, not data. From source to destinations. Okay. We're going to use that term source and destination. Sometimes we call the source, if we talk about equipment, the source is the transmitter. The destination would be the receiver. And the problem with communications Okay. We have what we call noises. Okay, and this noises is unpredictable, is random. Okay. And the noise going to mix with our information, also going to mix with our signal. And that make, so whatever we send, if we don't have noise, whatever we send, we're going to receive. But with noise, you may have some errors. Okay. So there are some uncertainties. And whenever you have uncertainty in your problem, not just communications, you're going to see probabilities. Okay. That means you cannot give the exact answers. Okay. When you deal with something with uncertainty, with something random, you cannot give the exact answers. But you still can give what we call, it's just like statistic. You cannot give exact answer, but you can give like the mean, the distributions. Okay. The probabilities of happening. So even we deal with random phenomena, we could still predict. We still could predict, and we could still say something about that. Very much using probability, statistics, and probabilities. Okay. In that case, let me just give you some tests. Let's see if you could answer probabilities. Okay. If I pick the number between 0 to 99, one number from 0 to 99, between 0 to 99. Okay. What's the chance that I'm going to get number 50? Can anyone tell me? That's 1 over 100. Thank you. Exactly. And okay. So the first time I pick, I get 50. Okay. And then the second time, I'm going to pick again a number between 0 to 99 again. What's the chance that I get the number 50 again? What's the chance that I get after I do the first pick? Now I do the second pick between 0 to 99. What's the chance that I get 50 again? Anyone want to guess? Okay. Good guess. But let me tell you this. I don't know, you may confuse with my questions. If I ask you, I pick one number out of 100 number, the probability is 1 over 100. Okay. And after the first pick, I take a look at this. I do it again, the second pick. The chance of picking 50 again is going to be the same, 1 over 100. That is because the first pick and the second pick, because they are independent. Okay, so we're going to have the chance 1 over 100 again. But if I ask you, what's the chance of picking the first time and get 50 and the second time get 50? That means I haven't picked at all. Okay, I'm going to ask you to do 2 pick. And if the first time I'm going to get 50 and the second time I'm going to get 50, that means 2 things have to happen. First time you need to get 50, and then second time you need to get 50. And the chance of that happening would be 1 over 10,000. You understand what I mean? But after I do the first pick, if I ask you what's the chance of the second pick I get 50 again, the answer have to be 1 over 100, because it doesn't matter what happened on the first pick. It's not going to affect the second pick. We call this concept independent. You have to understand what the independent means. Okay, if the first pick and the second pick, if they are not independent, then the answer would not be 1 over 100. Okay. This concept independent, and so your answers, some of your answer correct. Okay, but not for my questions. Okay. Questions. And if I ask you after I do the second pick, what's the chance that I do the third pick and I got 50 again? It's going to be 1 over 100 again. Okay. Only if I ask you before we do all the 3 picks that we're going to have 50, 50, and 50. That's going to be very less likely to get the same number 3 times. All right. Let me ask you more. You know how to calculate expected values. Yes, okay, good. Let me ask them. Do this. How about gambling? Yeah, gambling. Let's talk about gambling then. Good. Well, if you know probabilities, then you would you understand. Let's do this again. 1 over 100. Let's just make it the underground lottery. So the underground lottery, okay. So if you want 2-digit, we're going to bet for the two-digit number. We're going to bet for the 2-digit number. Okay. And every time you bet, you pay. Every time you bet, you put down 1 baht. Every time you bet, you put down 1 baht. Let me ask you this. The concept of expectation. Every time we bet, put down 1 baht. And the payout, if you bet 1 baht, the payout is, I think the current payout for this thing is about 65. 61. I want to find. This may not be that easy, but not difficult. Expected gain. Okay. What's the expected gain? After you make the bet like 100 times, what your expected gain? The gain could be minus. Two-digit number. Put 1 baht bet. When you win, you get 60 baht. You play it for 100 times. 100 times, 100 gain. What your expected gain? $60 multiplied by, all right, probability of winning, 60 minus 1 times probability of losing. 1 baht. Probability of losing. What is probability of losing then? Actually, you are approximately correct. Okay, but let me give you exact number because your equation is not exact, right? Because approximately. So basically, yep, you're going to, if you play 100 times, that means you're going to put down 100 baht, right? 1 baht for each game. Actually, we don't have to calculate. We just use sense first. If we play each game, and each game is 1 baht, we put down 1 baht for each game. And probability of winning is 1 over 100. If you talk about probability of winning is 1 over 100, that means on the average, you're going to win about 1 game per 100 game. For every 100 game, you're going to win about 1 game. Okay, that's the probability of winning is 1 over 100, and that means if I play 100 times, I'm going to put down 100 baht, and we expect to win about 1 game. And when we expect to win about 1 game, and that game we're going to get back 60 baht. So we're going to lose about 40 baht. We're going to lose about 40 baht. That's what our expected gain. Okay. And how we write that equations, and your friend equation is correct but not exact. So we say probabilities of winning, hold on, probability of winning is 1 over 100, and that means probability of losing is what? If winning is 1 over 100, losing is 99 over 100. And So now gain, probability of gain would be if we win, we're gonna get 60 baht. Okay, if we win, get 60 baht. If we lose 1 baht. We lose 1 baht. Actually, if we win, we don't get 60 baht. If we win, we're going to gain 59 baht. No, not 59. We're going to get 59 baht. You know why? Because we put down 1 baht, right? We put down 1 baht, and if we win, they give us back 60. So the benefit, the gain, if we talk about the gain, is 59 baht. It's 60 minus 1. So if to write your equations, we're going to gain 59 baht with the probability 1 over 100. Plus, we're going to gain minus 1 baht. That's like losing with probability of 99 over 100. And that is expected gain. So this is the gain. This is probabilities of each gain. So you multiply probability with what you're looking for, okay, and add them up. And this should be 59 over 100 minus and you're going to get minus this is for one game, okay? This is for one game. This is for one game. So per game, we expect to lose about 40 satang. If we play for 100 game, we multiply 100. Okay. So we expect to lose 100 and gain 5,900. This is for one game. So if 100 game, you expect to lose 100 times that. Expect to lose 40 baht. Okay. So basically the formula for expected values is that you're going to multiply the probabilities of each x to what you're looking for, okay? And then you would add them up. How many of them? Okay. 1, 2, 3. Let's. All right. Since we talk about this, let me ask you. So the payout here, actually, this is the payout for the undergrad lottery. They pay out about 60 baht. You know what is the fair payout? Fair game for this kind of game, if it's going to be fair. And let me tell you what the definition of fair. Definition of fair game is that it's a game that if you play in the long run, you go the expected gain going to be 0, meaning that expect to be equal. We're not going to gain any. We're going to lose, not going to lose any, and that's called fair game. Okay, that depends on totally on your luck. If you a little bit lucky, you probably get a little bit money. If you are lucky, you get below what expect. But if it come out as expect, we should not lose anything. So what is the fair payout for this game? You know? Fair payout for this game. The game that we're going to play a long time, and we expect not losing. And actually not winning. How much money if I bet $1? How much the dealer or should pay back? Guess. Anyone want to guess? 100 more. If you understand probability, then you will understand that all the gambling game are unfair and a lot unfair. If it's fair, I have to pay you 100 baht. Why? If the probability of winning is 1/100, and if they pay you 100 baht, if you win, that means on the average you're going to win about one game for every 100 game. So that means you put down 1 baht for each game, you lose 100 baht, and you're going to win one game and you get back that 100 baht. So that's and that means it's very, very difficult to beat those unfair games. You don't, you need more than lucky. Okay, you need to be very, very lucky. All right. So that, and okay, and then we come back, talk about communications. So now it's 3:00. So I'm going to give you 10-minute break. So this 15:01. Sorry. So let's break from 15:01 to 11. Okay,ครับ. Come back at 15:11. Let me turn off my camera. Okay, I'm back. Alright, so I'll give you a problem then. For example, if your grade, and this is probabilities, let's say A, B, C, D, F, and let's call this one X. Probability that, let's assume that a person with probability that contingent A is, let's say, 50%, 0.5, and probability that's going to get B 30%, and 10%, and this one 5%, F also 5%. So the probability add up to 1, right? 8, 9, 10. All right. And let's say A is 4.0 and B is 3.0, C 2, D is 1. So if we know this statistic, for this person, what the expected GPA, what would be the good guess, the expected GPA for this person of taking a class? Yes, okay, so now you understand the formula. Thank you. So you multiply the number to the probabilities and you add them up. 4 multiplied 0.5, 3 multiplied by 0.3, 2, 0.1, and 1, 2. Yes, thank you. Okay, so that's probabilities. Now let's come back to our communications. 3.15. Oh, thank you. I also, let's see, I'll send you the full of some slides. I have to tell you that I send you slides. We're going to go through those slides, but not in every detail. Okay, trying to go through those. In today's introduction, so let me get back to communication. So the communications, the objective communications, come back to this one again, is to send informations, okay, from the source to destinations. And we have problem. Actually, noise could come in anywhere, but most of the time come in channel. We call this the channel. Okay, the channel could be a wire channel, could be wireless. Wireless means the information go through the air. Okay, and that whole thing. And when we talk about communication, computer network, then this is computer network. So we need more than one computer to communicate. And we can try that. Hold on. Turn off. start to give you. Let's take a look at fluorescent slides a bit. Maybe not. Let's not start that first. Let's do this. I just ask you. So we're going to send information from source to destination, okay, and this channel. And I want to give you some technical term. If the communication is one way, that means it's only one person, only one machine send the information and another one just only receive one way. We call that simplex. Yeah, simplex. So it's like if I'm the only one who talk and you only listen, that's like one-way communication, so simplex. If two-way communications, we call duplex. Okay, because duplex, and there's two types of duplex. Okay. One type we call it half duplex. Half duplex is when you have half duplex is when you have one channel. Okay. So that means if one person send the information, another person need to listen. Okay. You cannot, the two person cannot send the signal at the same time, and that's called half duplex. If you think about the walkie-talkie, okay, we use only one channel, communication channel. So there's only one person could speak at one time. Okay. If two persons speak into the same channel, there's two signals would collide, and then we could not understand. Okay, the message. So that's called half duplex. But the communication today, most communication today is full duplex. That means you could listen and speak at the same time. That means we need to have at least that channel, at least to have two inside. So one way going to the left, one way going to the right. So this way, when we have full duplex, we could speak and listen at the same time. As two persons can speak at the same time, and that's called full duplex communications. The half duplex, you could think about the walkie-talkie. I think that's how to spell it. Okay. So the walkie-talkie, like the police radio, and when he speak, and then if he finished speaking, you have to give a signal to let the another person speak. In Thai, it's called like that being something like that. All right. So you know the term simplex, full duplex, half duplex. When we buy network equipment, you're going to see this term. But I believe now that we have all full duplex equipment. Before, when you buy hub or switch, there's like half duplex switch. Okay, so that's any questions, Cap? Any question at all? Hold on for 1 second. Any question at all? No. I like to start the informations, okay, just to get started. So we have the term sorry. We have the term informations. We have the term data. And we have also term signal. Okay. We're going to talk about informations here. We're sending data. Okay. Data is converted into signal and we send them. And within that data, there's some portion that we call informations. And what is not informations is something what we call redundancy. And actually, we don't need this redundancy. Okay, we don't need this redundancy. But first, we want to talk about informations now. And I have post this slide on the Google Classroom. A brief introduction. So we're going to take a look at a brief introduction to information theory. So this is a theory, okay? It's a branch of science that deal with the analysis of communication system. Okay, so you could say this, the graph here, we have source, we have destinations, we have channel, and we have noise. Okay, and before we put things into the channel, there's some encoder. There's many type of encoder. Okay, source encoding, error control encoding, encoder. And if we encode at the destination before the destination, we have to decode. Anything we do at the receiver, anything we do at the transmitter, we have to redo it, undo it, not redo it, undo it at the receiver. If we encode it, we have to decode. If we modulate, we have to do the demodulate. Okay. If we do source coding at the receiver, we have to do the error if we do the source decoding, we have to do source decoder decoding. If we do error control encoding at the receiver, we have to do error control decoding. And this theory is written, published by a guy named Shannon here. Okay, that's his name. 1948. That's long ago. So like you think of someone want to measure the informations in our data. So he would invent the way to do that. Okay. So, and in our case, the message will be sequence of binary bits. So we talk about binary data. By the way, when we talk about binary data, binary digit or digital data, that means our data have two symbols, okay? Two symbols, 0, 1, 0 and 1. So whatever our message is going to look like, it's going to be converted into 0 and 1. Okay. When we talk about 0 and 1, when we're sending 0 and 1, we're going to talk about that later. Okay, we need to create symbol to represent 1, create a symbol to represent 0. For example, in our computers, maybe when we talking about 0 could be like 0 volt pulse, and we talk about 1 symbol, it could be 5 volt. So that means what a computer could have two symbol. So when we talk about digital or binary digit, we talk about two symbol. Okay, it could be a black and white. It could be 0 volt and 5 volt. It could be minus 5 volt and 5 volt. So if we communicate using two symbol, okay, we call that digital communications. And you know why? You know why digital communication? What's the advantage of digital communication over analog communication? Anyone want to guess? Easy to store. Yes. That's one answer. Yes. Yes. Any other questions? Because we only have two type of symbol, right? 0 and 1. So that could make it easy to store. Just like if you have only two things, you can create the storage that only keep that two different things. The I think the obvious, or I think the most important advantage that digital have over analog is that it's better at fighting noises. Okay. Because we only have two symbols. If you think about analog signal, let's see, if I'm trying to give, if two person, okay, if I have a flashlight, and I'm going to send a message to my friend that like half 1 kilometer away, okay, I have a flashlight. If I'm sending analog signal, it's like I'm adjusting the brightness of the flashlight. Okay, so if I'm adjusting the brightness of the flashlight, I could adjust it up, adjust it down, up, down, up, down, and I could say that mean hello. Okay, so that's called analog communications, because my signal is continuous. My signal is continuous. But when we have digital communications, with that flashlight, I need only two symbols, maybe on and off. Okay, so I could say on, off, meaning hello. Okay, so when I do that on, off, meaning hello. if you think about it, it's much easier to detect two symbol on off than detecting the changing of brightness. Okay. And sometimes when we have noise, if you think about noise could be we have that day we have this foggy day or the lot of dust, and that means my friend on another side would not see clearly the intensity or the brightness of that flashlight. The digital signal also, when it's on, it's also not clear. Okay, but in a lot noisy environment, you're going to see that it's much easier to detect the digital signal because you only have to guess it's 1 or 0. Okay, and that's why when we have digital communication, the quality of the signal is much better at the end, because at the receiver, at the detector, when we have a lot of noise, all we have to do is guessing it's 1 or 0. So many times, even with noise, we could recover or make a right guess, and we could have almost perfect quality. So if you take a look at like digital TV, before we have like analog TV, right? You're going to see that digital TV is a lot sharper. Okay? But sometimes if you don't get it sharp, sometimes you don't get it at all. Okay, it's just collapse, right? So either you get good or not good. But with analog signal, sometimes you have blurry pictures. Sometimes you have when you have noise and you have like reflection, you could have like ghost phenomenon, like person walk with some like reflection, something like that. So that's one thing about digital signal, one advantage, and that's very important. And another advantage of digital signal over analog signal is that because we have computer. Okay, so computer take digital signal, and if we can put the signal into computer, we could do a lot of processing. We could take advantage of computer to do digital signal processing, and we could make thing what could make music much clearer. We can get rid of the noise using computer. We could you know do many things using what we call the digital signal processing. All right. And in this class, we're going to talk a lot about digital, okay, not a lot about analog. Okay. Now, one detail that makes communicating difficult is noise. Okay, and noise introduces uncertainties. Okay. And when noise introduces uncertainties, when noise with our signal make our signal uncertain, that's why you see probabilities. Okay, now let's look at the example. Suppose I wish to transmit 1 bit of information. 1 bit of information. That 1 bit could be 0 or 1, right? So the possibilities. So we have transmitter. We usually use TX. We call the transmitter. X is what at the receiver. So if we transmit a 0 and we receive 0, that's called good. Okay. If we transmit a 1 and then at the receiver, if we transmit 0 and at the receiver is receive it as 1, that's called error. Okay. And this also error. This is also good. So this is called digital channel. So for example, binary channel, if I draw channel look like that, 0, 0, 1. If I send the best channel, okay, if I send 0 and the probability of getting 0 is 100%. And if I send 1 and probability of sending 1 and receive 1 is 100%, this is called a perfect channel. Okay. You send 0, 100% you get 0, send 1. But in practice, you don't have perfect channel. You have noises, and the probability of getting it correct could be like maybe 80%. And then you have probabilities that you could get an error when you send 0 or 20% like that. Something like that. So the chance of sending 0 and get 0 is 80. The chance of sending 0 and get 1, 20. Okay. Same here. You may have 70% of getting it correct, and that means if sending 1 and get it correct is 70%, that means probability of error is 0.3 for sending a 1. Okay. And using this binary channel model, okay, we have not go anywhere about information that much. Okay, let me go back to my hold on. I'll draw here. Zero one. So this is at the transmitter, okay, the TX. At the receiver, we call it RX. And make it 80%. And this is 20% error here. Make it 70%. And 30% errors. Let's assume that probability that transmitted 0, okay, is make it 40%. So probability of transmitting a 1 must be 60% given. So it's like a computer. If you count number of 0 and count number of 1, you're going to see that this assume, okay, you can see that we transmit 1 bit 1 more than bit 0. So 60% transmit bit 1, 40% transmit bit 0. And with 0, after transmit at 0 going to the channel, it's called channel. 80% of the time we receive a 0, but 20% of the time we will receive 1. So that's error. Same here. If we transmit a 1, 30% we get error, 70% we got it correct. This look like. So the 0.8 here, if I write that in probability notations. That's called probability of receiving, let's call this, receiving a 0 given that 0 is transmitted. And this kind of notations we call, you know what that's called? That's called conditional probabilities. Have you heard of that before? Conditional probabilities. Given that we transmit 0, probability of receiving 0. And so 0.2 would be probability of receiving a 1 when we transmit a 0. Okay. 0.3 would be probability of receiving 0 given that 1 is transmitted. Probability of receiving 1 given that 1 is transmitted would be 0.4. Well, I'm not going to do that much mathematics. Get back here. Okay. All right. So that you know the possibilities of sending 0 and 1. Look like that one. So let's take a look. Now, let's give you a concept of information a bit. And the guy named Shannon here, he introduced the idea of self-information. So he wants to measure an information of some events. Okay, like with X here. So if you take a look, so there's uncertainty about that event, right? But we want to measure the information of that event. For example, if I'm tossing a die, okay, they have 6 symbol, right? 6 symbol, and let's say it's a fair die. So each symbol has probabilities of 1/6. We want to know that if we toss that die and we see the result, how much information do they get from knowing the result from that die? So if that die is called an information source, so if you look at information source is sending data, and the receiver take a look at that data, that symbol that the source sending to us, and we could determine the information from that source, okay, using probabilities. And that's the idea of how to measure the information by this guy named Shannon here. And he said that, let me say that the information's going to be inverse proportional to the probabilities of that event. What that means? Think it like this. This guy said that any event that have high probabilities there's going to be very small information within. For example, if I'm telling you that tomorrow the sun would rise in the east, okay, so that probability is 100%, right? So what I'm telling you is something that has probability of 100%. The Shannon guy said that there are no information in that message. That means you don't need to know. I don't have to tell you. Even I tell you, you don't get anything. There's zero information within that message. If I send that message to you or I don't send that message to you, it's the same thing. Okay. So he said that the information is actually is inverse proportional to the uncertainty, to the probability. So what if you have a lot of uncertainties, you have a lot of information when you know the message. If there are a lot of certainties, okay, you have very little information when you get that message. For example, if I have a die, and this is unfair die, and if I toss this die and every time I get number 1, so that's very certain, right? That I toss and I get 1. So when I toss that one and it's come out to be 1, we don't get that information at all. Actually, the source that or the die that give us the most information is the die with the most uncertainty, and that is the die that have equal probability for every symbol, like 6 that have the most uncertainty. And with that idea, he formed a formula to measure the information of the sources, okay, of the source. And so it's going to be inverse proportional to probabilities, okay, self-informations. And he put the log in front. The reason that a lot of the reason that we use log is that so like if we're tossing a coin, right? A coin, it's head or tail. So let's assume that probability of getting head 1/2, probability of getting tail is 1/2. If I'm tossing 2 times, so the first time and the second time, okay, and we have the probability that I'm going to get head both times would be 1/2 times 1/2. Okay. Times 1/2. So the information that I get from these 2 times, if we want to measure, is information from this term plus this term. It's the plus. Actually, the information should add. So the one thing about log is that it's making the multiplication become summations. Okay. Summations. So that use log, and so the cell information is going to be log, and we use log of 2 of 1 over that symbol. Okay. And so we could write in a short way it's like that, log of 2 of 1 over p. And then if we move p up, we have to put the minus in front. So self-information of an event like information for the head or tail, for example. It's going to be 1/1/2 log 2 of 1/1/2. So that's how they measures. Now, suppose we have an event X, where Xi represent particular outcome of the event. Consider flipping a fair coin here. There are two equivalent outcome, head or tail, 1/2 and 1/2. So we're going to add the information of getting head and tail. That's going to be log 2 of 1/1/2 plus log 2 information for the head and information for the tail is log 2 of 1/1/2. And that we're going to have 1 bit if you calculate. So a coin here with probability 1/2. When we calculate the information for the source, we're going to have 1 bit per symbol on the average. Okay, it's 1 bit per symbol. I'm sorry. If we calculating the average or the expected informations, we have informations, right? This is information, and we calculate expected, we have to multiply by probability in front. Probability of getting tail is 1/2 multiplied by information of tail, which is log 2 of 1/2, 1/1/2, plus probability of getting head, which is 1/2, multiplied by informations of head, which is log 2 of 1/1/2, and you're going to get 1 bit. So that's the average. So it's 1 bit per symbol. A head is called 1 symbol, a tail is called 1 symbol. So it's called 1 bit per symbol. And that means when we show it's a head or tail, okay, we get the information of 1 bit. Well, I could show you more example on that, but take a look. This one, when the outcome are equally, we're not going to do calculation that much, but you have to get the sense, okay, of the equations. When the outcome are equally, there's a lot of information in the result. Why when they are equally, you have a lot of information? Because when you have equally, that's when you have the most uncertainties. Okay, you have the most uncertainties, like a die, right? If each phase is 1/6, 1/6, 1/6, that's the most difficult to guess. So that you have most uncertainties. That means you have most information. But if a die with some more certainty on one phase, that die have less information. The higher the likelihood of particular outcome, the less information outcome conveys. Okay. However, if the coin here is biased, such it's land with head up 99%, so that's a lot of certainty, right? There's not much information conveyed when we flip. So that's concept of information. So you have any questions? Okay, I'm gonna let you go on this time. โอเคครับ I'll see you on Thursday. No homework yet. I will assign you next time. Nice to meet you. Okay. Bye.
Thank you อาจารย์ บ๊ายบาย
Thank you. Bye.